to be here. And I'm not kidding. I am very excited to be here. Like, I've missed this, even though you guys won't talk to me, right? I still missed the fact that I could be in front of a room. Okay, so we're going to learn now. If you have notes, get your notebooks out, get your pens. Does anybody need a pen or a pencil? No? Okay, all right. Good. This is the thing. I don't need glasses, but I wear them because when I shift my field of my focus from something very close to something very far, I tend to get dizzy. So like my eyesight's fairly good, but like whenever I wear a mask, I don't wear my glasses because they get all fogged up, right? It sucks, right, Nicholas? Right? You know what I'm saying? It sucks. So there's going to be times where I have to take the glasses off. Okay, you guys should write these down in your notes. And I'm just going to stand up here and talk for a little bit while you're writing them down. So the trigonometric identities that we need to know. And this is where we start what we're going to start this unit. And I said yesterday, it's weird. It's the best thing I can, it's silly for me to even say that. But you'll get a handle for it the more we do. These three identities right here, the ones that have all the squareds in them, these are called the Pythagorean identities. Pythagorean, if you will. I say Pythagorean, okay? These are the Pythagorean or Pythagorean identities. They're Pythagorean identities because they have squared values, right? For lack of a better word. There's probably a deeper explanation for that, but we'll leave it at that. These guys, I cut that one short. Might need to calibrate this board. These guys are called what I call the reciprocal identities. Okay? The reciprocal identities. We've seen these before. We talked about how cosecant is the reciprocal of sine. We've talked about how secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay? But before, we were talking about flipping fractions over. Now, when we talk about them being reciprocals, we're looking at doing a different kind of substitution. Okay? Something worth noting, and I'll put this in here, okay? I know I've mentioned this before, but I will say it again. Sine squared theta is really sine theta squared. It's just faster to write it that way. We're going to do something a little different with these today. You'll see what that looks like here in a minute, all right? What I'm going to tell you now, and you're going to hear me say over and over and over again for the next week, okay, is that there is a connection between sine squared and cosine squared. This is the connection that I'm talking about, okay? And again, I'm going to speak just kind of in some vague ambiguity for right now, and just say eventually, when I say, well, you see this sine squared, what should you be thinking? You should be thinking cosine squared, because there's this connection. There's a connection between tangent squared and secant squared. Okay? There is no connection between tangent and secant. It's between tangent squared and secant squared. Okay? There's a connection between cotangent squared and cosecant squared, but not between cotangent and cosecant. I know that sounds kind of strange. Okay? We've said this before. When you see cosecant, you should be thinking sine, right? What that meant before was, can I do this? What that meant before was, when I was asking you to do what's the cosecant of pi over 4, this is going back a little bit, but I used to say, don't think about this, think about this. And then when you get your answer to that, flip it over, right? So the answer was 2 over radical 2. And then we would simplify that, okay? This is how we talked about the reciprocals before. We're kind of changing that, Now when we talk about the reciprocals, it's substituting this in place of that and vice versa. Okay? The other thing I'll mention about these Pythagorean identities, and you may want to write this down in your notes, maybe not. It might be a bit much to start with. But we have this as the basic Pythagorean identity. All right? This is something that this should be like a squared plus b squared equals c squared. And you all know that. Okay, y equals mx plus b, you kind of have these variable type equations and statements that should be ingrained in your memory. This should be one of them. Okay, now, don't focus so much on what theta is, because we also will see this written with x's. That doesn't change it one bit. Not one bit. Okay, this and this are the same exact thing. The one thing that I will say is this is like these are, okay, the way we typically write these. This is what you should memorize, okay? However, there's going to be some manipulation of this, meaning there's going to be a time where I want this cosine squared x to be over here. So this statement okay, is just as useful, and in some regards more useful than that statement. It's just a reinterpretation of the same relationship. Okay? And again, you'll see what I mean once we start going. I'm just trying to set this up for right now. Right? Just trying to set you up. And I could do the same thing. I could subtract sine squared to the other side. I could have a statement that says cosine squared x equals 1 minus sine squared x. Okay? I could keep writing more and more of these. Just understand that when we start with this, we can move pieces to the other side. Right? Just one more quick one, and I don't want to overwhelm you right off the bat, but I could do this. Okay? Stay with me. Because we're going to need to do this as well. If we start with this statement, I could move this 1 over to here by subtracting it, and at the same time, move this sine squared over here by subtracting it, and end up with a statement that says cosine squared x minus 1 is equal to negative sine squared x. That's another type of manipulation I can make with this statement. I can subtract this over to here, and at the same time, I can subtract this over to here. Okay? We manipulate that statement to, and I'm going to say this again a lot over the next week or so, we can manipulate this statement to fit what we want it to look like. Okay? You'll see what I mean here in a second. So this is the manipulation of a Pythagorean identity. Now I'm going to pause this because the video is getting a little long.